To avoid detection, attackers will also abuse other network protocols. A common technique is DNS tunneling, where the attacker will establish a communication channel over the DNS protocol. Similar attacks are domain generation algorithms, DGA for short. Alternative covert communication channels can be set up over ICMP as well. To get a better understanding of this, we'll continue with more details on DNS tunneling. Since DNS is a whitelisted protocol designed to facilitate addresses for domain names, attackers will use this to establish a communication channel that bypasses firewalls. The infected machine will generate a DNS query for the malicious domain with some encoded data as the subdomain. The encoded data might contain results from a previous command issued by the attacker. In response, the attacker will provide the command as an encoded payload. This will be decoded and executed by the client. The result of the command will be part of the next client request. Another technique leveraged by adversaries to stay ahead of blacklisted domains is DGA. Domain generation algorithms are based on domains that are dynamically generated, oftentimes based on a seed value and the date and time. Knowing the formula, attackers will register some of the domains for the seed value and the date and time in the future. When the date is reached, the malware can connect to the C2 infrastructure. Let's consider the following scenario. Domains can be generated based on the following formula, which consists of the day concatenating with a month, year, hour, and seed. As the malware persists on the infected machine, it will cycle through these domains based on the current date and time. Attackers will register some of these domains in advance, and when the specific date and time match, the malware can establish a connection with the C2 infrastructure. To detect DGA as well as DNS tunneling, we can consider the following facts. The domain names will contain random characters. Domains will have an increased length. And we can also apply beacon detection tactics, meaning that we can look for a high amount of requests at a periodic intervals of time. Since these domains will only be used by attackers, we can expect a reduced frequency of occurrence against the baseline traffic. It's time for another interesting demo, where we will be attempting to detect DNS cat activity with the Zik IDS logs in our Elastic instance. This scenario builds on the previous attack scenario. Looking at the top DNS domains once again, we can identify a large number of unique domains corresponding to the globalmantics.com domain. For this part of the investigation, we'll be using the PacketBit dashboard. We'll expand the transaction type graph to get more holistic view on the traffic, and we can notice some spikes. Looking at the other information, we see also that there are a large amount of DNS errors. We'll narrow the time window to this period. Going back to the transaction type, we see that the spike in DNS activity is a bit more defined. PacketBit has also a specific dashboard for DNS tunneling activity, and here globalmantics is identified with high fidelity. We'll continue the investigation in the Discover tab. Using the filebit index, which contains information from the Zik IDS, we look for this domain in the query field. Expanding one of the events, we can identify also the source and destination IP. And we'll add this as a column to get a better view. And we can see that we have large queries to evil.globalmantics.com, including an encoded payload. In summary, we have managed to successfully identify DNS tunneling.